Okay, let's have a look at this question. How long will it take in years and months for $400 to quadruple in value if it earns interest at 3.97% compounded quarterly? Okay, so let's get the compounding frequency first. It's quarterly. So PY equals CY, that's 4. Quarterly means 4 times per year. Okay, let's fill in these boxes sequentially. And we have to go before sequentially in terms of the calculator. So IY is 3.97. Let's copy and paste it in here. And maybe we can start our calculator. So second IY, CY is 4, and so is CY. So we will quit or exit that menu. And we are looking for the years and months, or we have to get the value for n. So that means this here, the years and months, means we will have to compute n. So that is where the computation lies. Now the interest rate is 3.97, so we go 3.97 interest rate. What else? Next is the present value, and that is $400 right there. So let us copy and paste it in here. The payment is 0. In the future value, it says to quadruple, so 400 times 4. Quadruple means 4 times. So 400 times 4 is equal to 1600. So 1600 will go in the future value. Okay, so let's continue the entries. We have the high Y value in there. The present value is 400. Let's put that in, 400, present value, 0 for the payment. And we should put the future value in as negative. Well, why? Because the future value has to have the opposite sign to the present value. Or we could put the present value in as negative. Either decision will work. So let us now compute n, and we get 140.369. Now that is what? That is the number of compounding periods for the duration of the time the $400 increases to $1,600. Okay? So to get the number of years, we have to take n and divide it by what? Yes, divided by 4. So we will have to take that divided by 4, and we get 35 years. Okay? And now we have to subtract the 35 and get the rest of the year. And that we multiply by 12, and we get the answer of 1.1 months, and that has to be rounded to the value of 2. All right, let's check the answer and see what happens, and the answer is correct. Okay, so that seems to work. Now, remember I told you that these signs, present value is positive, future value is negative. Let's say we go back and make the future value positive, right? That is positive, the present value is positive, and then we try to compute n. See, we get an error of 5, right? So if you see that, you know that You must recall one of these, either the present value or the future value, and make it positive, and there we have an answer. Okay, so there we are. Now you might be wondering, why aren't we rounding these? Let's say we did round it to 141 because you cannot go in between. It depends on how the number has to be a whole number. So if we were to go with 141 and we divide by 4, the PY value, there it goes, 35.25. Now the 35 is correct. If we were to subtract the 35, there we are, we have 0.25, we multiply that by 12, and we will get an answer of 3. Now let's say if we put in the 3, what happens? And the answer comes out to be incorrect, which is not what we want. So we will have to change that back to 2, and therefore we get the correct answer. So we should not round the number of years and months in this case. You're not told to round the answer, so it should not be done. Okay, let's go to the next question. Okay, find the effective rate of interest of an investment that earns 3.4% compounded monthly. So we're finding here, we are computing the effective rate, correct? So there we are, sorry, repeat the effective rate. And we are given the nominal rate, which is 3.4. Okay, so there we copy and we paste it in there. And it is compounded monthly. So that means that CY is 12. Okay, so there we are. All right. So let us go. We know how to get to do the effective. We have to use this I convert. So we go second 2, and there we are. We enter now the nominal amount, which is 3.4. We go past the effective, and then we go to CY, which now is 12. Enter it, and we go back to effective, and we compute, and that should be the correct answer, 3.45, 2 decimal places, so we are safe. Okay, for the effective rate. That's around the effective rate to 2 decimal places. So we check the answer, and the answer is correct right over here. Okay, the next question. We're asked to convert 2.55% compounded quarterly. So the 2.55% goes in here. It is compounded quarterly. So this CY would be 4. And then we find the equivalent interest rate. We want to find the equivalent interest rate compounded monthly. So that means that this number here would be 12. Right? So we have to compute this effective first. So we use these 2 bits of information, the nominal and the CY, to get the effective, which is this right here. So let's put those numbers in. So let's put the 2.55, 2.55, enter, and compound it quarterly. So we go down, and CY is 4. We enter that. We go back to the effective here, and then we compute that. And that answer turns out to be 2.5748. Maybe we should use 5 decimal places. That's wrong, the effective rate to 4 decimal places. So we have 4, so it's best if we use 5. All right, just to be safe. Now CY is 12, so we can drop down here and put in 12 for CY. And we go back to nominal and we compute and we get the answer. It's 4 decimal places, so 2.5446. And that should be correct. Let's see if we are correct. And we are correct. Now let's see if we are negligent and say we do not round. And we do that, you will see what will happen. The answer turns out to be incorrect. We have to do the rounding. There we are. Okay, so it's safer if we go past the 4 decimal places. Okay, so there we are. All right, so next question, we have deposit. Tallulah deposit $5,410 at the end. Now this is one where we have to classify what kind of annuity it is. So it's at the end of every 3 months. All right, it's every 3 months. So that means that PY is 4. And the compounding is yearly. So that means CY is 1. Okay, so that is what we have. So we have an end. Remember those kinds of annuities? So we have 4 kinds. So let's go maybe and look into the Word document. And let's go back here, maybe copy this, and then we can do the analysis to come out with the correct answer. All right, so here we are. So we have, let's bold it maybe, and highlight end. So end is important. We need that. And every 3 months, so this is also important. Let's change the color to something else. And let's say compounded yearly. We can use another different color. Let's say we use this one here. Okay, so what we have is end. Then we have what? PY is equal to 4. That came from this here, that the deposits are every 3 months. And the next one is a CY. That is equal to 1. It's annual. So here we have an end, and PY is not equal to CY. So this is what? Well, this would be an ordinary general annuity. Okay, because it's at the end, it's ordinary. And because PY is not equal to CY, it's a general. It's an ordinary general annuity. So we go back and then we make our selection, ordinary general annuity. We check the answer. The answer is correct. And we got the 10 points. Okay, so let's go to the next question. All right, suppose you deposit $490 at the end of every 6 months for 3 years into an account, earning 3.21% compounded semi-annually. After these 3 years, you leave the money in the account without making additional deposits for another 19 years. Invested at the same interest rate of 3.21% compounded semi-annually. All right. How much will you have in the account after 3 years? So after 3 years, that is the first part right here. Okay? So your deposits are being made of $490 at the end of every 6 months. At the end of every 6 months, so that means that PY is 2. And it's compounded semi-annually, so that means CY is also 2. Okay? All right. Now, what else is there? The interest rate is 3.21%. So let's put that in there. And what else do we have? Well, deposit of $490. So that deposit is a payment. And we can put it as negative because it's being placed into the account. It is going out of the person's possession. So the present value is 0. And then the future value is what will need to be computed. Okay, so that's where the computation will take place. All right, at least for this first part. So let's start. Let's come out of here. Let's clear, and then we go in there. So PY is 2, enter, and so is PY. And out of there, and it is for 3 years. Okay, so 3 years, second, and N turns out to be 6. All right, IY is 3.21, 3.21. The present value, sorry, is 0, as it is right here. The payment is negative $490, so 490 negative payment. Then we will compute the future value. Right? So we compute the future value and we go in compute future value and we get this answer of 3,060.52. We round to 2 decimal places. All right, so that future value will now become the present value down here. Okay, all right. For the next part of the calculation. Now, the deposit stop after these 3 years. You leave the money in the account without making additional deposits for another 19 years. Okay, so since there are no more deposits, the payment will become 0 now. And that part will be there for 19 years. Invested at the same interest rate of 3.21 compounded semi-annually. So the interest rate is 3.21 compounded semi-annually, means CY equals CY is equal to 2. And then how much will be in the account after the entire 22 years? So this future value we will need to, we will compute the future value. Okay, so let's go again. So the CY and CY, they're still 2, so we don't need to worry about that. The N now is 22 years, but remember, 3 years have passed. Okay, that's why it says after these 3 years, you leave the money in the account without making an additional deposit for another 19 years. So to calculate N, we will use 19 years. So 19 second and N. So N turns out to be 38. Right, now the interest rate remains the same. So if you recall that, we get 3.21. Now the present value is what we have to change to this number. There's 3,060.52. And we can put it in present value. Right, so 0 for the payment. And then we compute the future value, and that should be the correct answer. 5,000, sorry, it should be over here. $5,604.91. But let's put a 91. That would be the correct answer, rounded. And let's check it, and it is correct. But of course, my advice to you is that if you're unsure about rounding, then you should put 3 decimal places, and there it is right there, 905. Okay, I will stop here and for today.